Now,
Fantastic.
the TST meeting. So we have one agenda item, which is to talk about the Napatech collaborator proposal. And why don't we just jump right into that? And one of you wants to give us just a little bit of an overview. I mean, we can all, of course, read it, but just to give us a sense of what you want to do.
Sure. I see my colleague Michael's on. Michael, you want to take the lead there?
Yeah, sure. Can you hear me?
Yep.
Yes, absolutely.
Okay, good. Yeah. So one of the things we are proposing basically is to come up with some acceleration for in-band telemetry inside OVS, along with S-flow acceleration inside OVS also. And this is mainly due to the understanding that we have is that the loop 0 of the A Cord is very latency sensitive. So having for instance, S-flow accelerated by hardware will dramatically reduce the latencies from generation of these records to reception, because they don't need to be generated inside software and then sent out across the network. They're being generated by the network itself, basically. So that's one of the proposals. And the other one is basically taking the in-band telemetry that runs inside Trellis and have that run inside OVS also. I don't think that's possible today because OVS doesn't have any in-band telemetry support. And also there's a problem, at least that I can see, is that the VXLAN tunnels are being terminated by OVS. So you lose the int inside OVS. So our proposal basically is to make OVS int aware, basically, letting you have int support and thereby have a full end-to-end latency measurements from well, basically all the way through the network.
Thanks.
Are there any APIs from the int that you could actually collect what you need? Are there any plans for that, or?
An API?
Yeah. How would you drive the int inside OVS in terms of, turning things off or on, to make sure they don't have any impact on the OVS performance?
Yeah, so that is something that that needs to be done on a per port basis. Basically, like you do today when you activate the tap functionality or span ports. That is an OVS action you perform on the specific OVS ports. We envision that the int will work the same way, so that you activate int on a per port basis, and if that port is able to run int in hardware, it will run in hardware. If it's not able to run in hardware, let's say that port is residing on a Intel NIC or even on a it's a software port. Then if you activate int, then int will be running in software, of course, and that will affect performance.
Is there a generic way to turn on and off this on the NIC, the hardware acceleration, such that if another vendor came up with hardware acceleration, it could be used as well?
Yeah, so normally when we do initiatives inside OVS, we try to, or we strive to make them generic in a way that others can do the same thing. We have done that already with a partial hardware acceleration of flow record, of megaflows inside OVS. So we teamed up with Mellanox and came up with a generic solution that work across all NICs that have these hardware capabilities, and we think that the same thing can be done with int. So if you have a secondary vendor that has the capability of doing some programming inside the NIC, that they'll be able to use the same APIs.
And you're going to provide the functionality as part of your contribution that does the magic if no accelerated hardware is available?
Yeah, so the intent here is to, as I've written in the scope, and also is to enable the int feature. No matter if it runs in hardware, it runs in hardware. But if there's no hardware capability, we will make a software solution for that also.
All right, thank you.
So,
Are you looking at P4 support for this feature? So the INT that you're looking at implementing, have you looked at the P4 spec?
I've looked at the P4 spec, yes. Unfortunately, P4 it's a matter of efficiency, you can say. So having P4 converted to RTL and then being then again compiled into to bitcode, there's a lot of overhead in that. Of course, like if you have an ASIC that has P4 support, it's easy to do this P4 in-band telemetry. On the other hand, I think from an Napatech point of view, we will start off making a binary RTL version of int rather than go directly to having a P4 implementation. But we will definitely be implementing what is inside the P4 int specification.
so I wanted to ask Bora, who I'm pretty sure is hopefully still on, and you folks, if you have talked about how to integrate all this into the broader telemetry as a service plan.
Yeah, exactly. So, I mean, the proposal looks very good because in-band telemetry is truly a very good value add to monitoring, and we can definitely have this and integrate it with Cord, and this will also create some compelling and exciting demo use cases as well, as far as I can see. So this really sounds like a logical proposal to me. But I have a little question. Did you actually have you actually done some proof of concepts of this? Because it's software I just cannot, see how it's going to work, because in-band telemetry requires a significant amount of processing power.
Yeah, so to be honest, we don't have any prototype running yet because we wanted to get the kind of the insight if this was at all something that was beneficial to do in hardware from a use case point of view. So once we have this approval, and it seems like you guys can definitely see the benefit from having this inside OVS and inside hardware also, that we will probably start up doing some experimentation on this. From an FPGA point of view, I don't think that the in-band telemetry implementation in hardware is that big of a deal, because we do some complicated stuff already that is more complicated than int without any problems. So just inserting and so just to be a hub. A P4 int hub is not difficult. The difficult part comes in when you have to be a proxy, and that's definitely something we need to look at. And the proxy comes in when you have a VNF that is not int aware, because there you have to implement a cache saying that strip off int before it goes to the VM. When the packet comes returns, identify the packet. Get the data from the cache and then piggyback it onto the packet again, and that's definitely going to be one of the biggest tasks. But we have mechanisms already at hand where we can fit this in. So it's in our view, it's just a matter of basically getting to the editor and start writing some code.
Okay, that sounds good.
So there's some work by the P4 Brigade to start putting in some northbound behaviors to enable INT collection. You may want to look at that effort because that would allow you to do applications on ONOS and be able to turn on and off this functionality. Because part of it is we're looking at possibly lower level knobs to actually specify the headers, right, that you would enable to determine the data that would be collected.
Okay. Thanks.
So it's taken a while to unmute. I'm not, suddenly it seems that GoToMeeting is concerned about how many of us are unmuted. Do you have a fairly short-term POC in mind, a proof of concept in mind? It'd be nice to see a fairly near-term milestone that we could all agree was helpful.
Yeah, so I would, if I were to choose how this project should go, we would start off with having a software implementation inside OVS, showing that this is viable. This is how you turn it on. This is how you turn it off, and then showing that it is possible to basically have P4 int going into OVS and back out again. That would be the very simple solution. So basically, not doing the proxy, but have a VNF, a dummy VNF that basically is P4 int aware and just loops the packets around, so that you can see that OVS ports actually inject this timestamp information and switch port information that is needed for the end-band telemetry.
Okay, that sounds perfect. Moving on to the demo proof of concept, just beyond that one, and this I'm going to open the floor a little bit more broadly, maybe to Bora or Oz in Cord or someone else. Do we see an opportunity to do let me call it include this in an end-to-end demo of some sort?
Bora speaking. I think yes, there can be demos, but first we need to see the functionality, I guess, and come up with some suitable demo scenarios. We need to know about the capacity, performance of the OVS, which will have in-band telemetry implemented in.
Okay, so yeah, I completely appreciate that. So let me try to sketch let me call it a path to deployment here, or a path to inclusion. I'm always concerned, you have a perfectly reasonable first step demonstration, and then you move to something a little bit more connected to the rest of the system, where of course I'd like to see is that this eventually find its way into release 6.0 or 7.0 or somewhere down the line. And so this is more just my advice would be, after this first demonstration, we look for opportunities to connect this capability into one of the R-Cord demos or M-Cord demos or E-Cord demos. And once it's there, then the next step is to make sure it gets integrated into the next release. So that would be my advice, is to always watch for that ability to get the idea onto the release train.
There's some talk of an INT demo at layer 1, 2, 3. So we can see if we can connect this up. I think there is also talk of some inclusion of INT into the ONS demo, but I think that's going to be pretty tough with the timeline between MWC and ONS.
Okay, well that's good. That's exactly what we need to see. Any other people have questions? Or do any of the Napatech folks have questions?
Yeah, I have a question actually. how do you do the P4 int today? Because as I understand it, it only runs in the inside trailers, so basically inside the leaf spine network. So I guess you have a sync right before you hit the V switches. Is that correct?
Maybe you can answer to that. This is Carmelo. Sorry, I had some troubles joining this call. This is not what we do right now, but this is the plan. The plan is to exactly implement the sync functionality in the leaf right before hitting the server.
Yeah, but if you only do that, then you lose the end-to-end latency, right? I mean, this is. I guess what I'm asking is if this effort we're doing is well spent, if there actually is a use case, or if you can say right now that but we just terminate on the leaves and we don't actually want to go inside OVS, but I can't see that you can get the end-to-end latencies by only having leaf syncs.
Yeah. So yeah, don't get me wrong. I mean, this is the plan right now because I mean we've been working mostly with P4 switches.
Yes.
But if we have support for INT capabilities in the NIC card, clearly that's a benefit for us because as you said, we have end-to-end visibility.
Yeah.
Yeah.
Okay. Good.
So I'm in favor of that. I'm totally in favor of that.
Good.
Yeah, and you will help push that along.
Oh yeah, sure.
I mean, that's part of the value here is that you bring that next capability and champion it through use cases.
Yeah. Yeah, but I just wanted to be sure that it is actually useful because it's going to take some time to implement, and it will be bad if you could just set out front that but we're not going to use it because we have 2 weeks where we can get kind of the end-to-end latencies in other ways. So that's good. What kind of overlays would you be running? Is that VXLAN only? Normally?
Yeah, right now, for what I know, VPN uses only VXLAN.
Okay.
Yeah, that's what we're doing today, and that will be a reasonable target for you.
Okay.
I have another suggestion. So this sounds very much like what we've done in eCord, where we built specifically for layer 2 VPNs. So it's a layer 2 kind of in-band telemetry solution that we built with microsemi. So it does not go from OVS to OVS, but really from CPE to CPE. And so we spent quite a lot of time, what Tom mentioned, thinking about the APIs that we should expose to ONOS for this. There's also like a component that visualizes some of these parameters in XOS. So my suggestion would be to at least take a look at that work and see if there's any reusable parts there or things that you can be made reusable for your specific use case.
Yeah, sure. Could you set a pointer?
Yes,
so
yeah, happy to do that. No problem.
Good.
And also regarding the VXLAN question, I joined late the call, so maybe I already missed that part. But so right now, traffic in the fabric and coming in and out of the NIC cards is not just VXLAN. We have use cases like, for example, in the M-Core demo we're working on right now, in which we have a physical OS that is talking to a VM inside a server. We call this flat network. In that case, there is no VXLAN encapsulation. At the same time, it's also very important to have some visibility there.
Okay, so do you plan to use, or are you planning to use the TCP options?
Yeah.
Extension, basically having the embedded inside TCP options.
Actually, in the P4 Brigade meetings, we've been talking about using the UDP options, but I don't see any problems supporting the TCP options.
Any other questions or comments from anyone?
So this is Sven from Napotech. Do you have a roadmap for the demos you are planning, so we can try to see how we can fit our plans into that?
Yeah, that's a great question. We do, but I don't know that they're where they're posted. So it's sort of in the collective, everyone's collective knowledge. Yen, do we have a place that we can help people follow?
We can work on it. So we'll kind of aggregate the info and let folks know.
Yeah, so it's just because we have some ideas on how we would proceed here, and it would be very good if you can align this with your plans also, so you're not wasting time on working on things that are not needed at the point in time, and you are waiting for something.
Okay, and I think part of it is like Carmelo said, right? The INT effort is in progress, so we want to make sure that you're aligned with that effort, and not assume it's done yet.
Okay.
Okay.
And also, we'll share all the technical documentation we have so far about this INT work we have inside the P4 Brigade.
Perfect, thanks. Well, let me just do a call out to the TST members. Everyone okay with this? Any other concerns or advice? Not hearing any, I take that as unanimous consent. So thanks for bringing this to us. I think the key to success is that you take it and run. When we will do everything we can to connect you with like-minded projects and make you aware of various demos and proofs of concepts and things that are on the horizon that might influence the timeline. I guess that's everything. So are there any other, so thanks a lot. Are there any other topics anyone needs to discuss? All right.
Larry, thank you for the opportunity. This is CJ.
I'm sorry? All right, I'm not sure what that was, but I didn't quite catch that. But I'll follow up with the Napotech folks and just make this official. And I think we'll just call it a day. Thanks, everybody.
Okay, thank you.
All right.
Bye.
Bye.
Thank you.
Thank you. Bye bye.